Hey guys, we're back with the notes for 8.6. We are still graphing polynomials, but now the focus is identifying more of the components because you will get a calculator to access this, okay? All right, so let's start by having you pause, copy the pink, and then we'll talk about it. Perfect. And then I'm gonna have you pause again real quick and copy the blue, and then we can talk. Perfect. All right. So starting with the pink, I'm not going to read you all of this. Basically, in Algebra 1, they kind of spin it and explain it like zeros, factors, solutions, roots, x-intercepts. Those are all the exact same thing. Well, kind of. A zero is a singular value for a polynomial. So I can say like 3 is a zero on this polynomial. That's the same as saying it's a solution to an equation. So if I make it, instead of an expression, if I actually put an equal 0 on the end, then I'm saying that x makes the equation equal 0. Okay, it's a solution. If I think about that polynomial on a graph, I can still say that k value, that 0, that solution, is on the x-axis. He's my x-intercept. But the big difference I want to make sure you understand is a factor is actually has to be f of x. I can't just say polynomial f. I have to use in terms of which variable. So I have to make sure I remember that we're changing the signs, which you know, but I'm just reminding you. Make sure you know the difference between these vocabulary words, okay? All right, let's talk about mins and maxes. Okay, we know in a basic function, maximum means the highest point, minimum means the lowest point. But when we're talking about polynomials, you're going to have more than one type of maximum and minimum. You're going to have relative minimum and maximum, which means he's like the highest around here or the lowest around here, but he's not the highest of the whole polynomial. He's not the lowest of the whole polynomial. That would be called absolute. So let's talk about relative first. First of all, relative min and max have to do with the y values. I cannot stress that enough. We are only giving y values. You don't name the whole point, okay? Y values. So a relative max would be the highest point in general. So it would not be this guy. This is not a relative max, okay? It's just the highest bump in the moment. Relative max has to be the highest in general distinguishable point on the graph. Relative min, okay? Relative min is the lowest in general problem on the graph, not the absolute, not the whole thing, but the relative in that area. So this would be a relative min. This would not. This would be a relative min. This would not. Because that second one that I just put an X on, let me get rid of this guy again. This guy, this guy isn't a relative min at all. He is the lowest point on that entire graph. He's the lowest part of the W completely. So relative and absolute can exist on the same graph. Okay? Next thing I need you to know is not every graph has an absolute. Odd functions, so anything that is moving in opposite directions like this, or anything that is moving in opposite directions like this, they are going to have a range that goes forever, right? All the way down to negative infinity, all the way up to positive infinity. They would not have any they would not have any absolute mins or maxes. Those would be infinity, and we don't list infinity as an absolute, okay? So they would have relative only. That is something important to know because you will see the question on every problem whether you need it or not, okay? All right, let's go ahead and have you pause the screen, copy number 1, what's already on there, and then we'll get started. Perfect. Okay, so you do get technology now. I'm going to go ahead and bust out my graphing calculator. If you are at home as a remote learner, obviously you're using Desmos. It should be very easy to do on Desmos. We have a few more buttons on this calculator, which is why I chose to do the notes with this one instead, okay? All right, so I'm going to start by getting my equation all typed in, plus 1. Now, I do not need the table. You're not even going to have any numbers on your graphs when I ask you to draw them. What I need you to understand is critical points. That's anywhere you touch the x-axis, anywhere you touch the y-axis, and any relative mins or maxes that you might have, okay? All right, so let's start with some things that we know already. First of all, from the equation, I already know that it's an odd function. That means it's going to be all real numbers, or negative infinity to infinity for both the domain and range, okay? I've got that covered. Second of all, I already know the y-intercept. The y-intercept is going to be 1. It's going to be 1 because this last number, the constant right here, is a 1. So I'm going to put my first dot on that, and I'm going to label him a 1. I know my total number of roots. I don't know if they're real or imaginary right now, but I know that whatever my degree is, that's my total number of roots, so 3. All right, looking at my graph right now, if I come over here, I can see that I hit the x-axis 3 separate times. So I'm going to have 3 real roots. I don't know what they are yet, but I do not have any imaginary roots. I'm going to put commas here so that we can get all 3 of them. Let's show you how to do that. On these calculators, you are going to go, let me write it. Let's go over here. Let's go menu. Woo. Menu, trace, graph trace. And what that's going to do is you're going to look for the words 0 over and over and over until you find them all. So menu, trace, graph trace. Start over here with the first one. My first 0, see how it tags it with the word 0? Let me show you one more time. Tags it with the word 0. I want this first x number. So negative 1.7. I'm going to use my arrow to the right, oops, this way, till I find the next one, and it's 0.239. Use my arrow to the right until I get my next one, and it is 2.46. Now, I do need to go ahead and put those on my graph right now. So I've got negative 1.7. I've got 0.23, so it's really close right here. And I've got 2.46. Okay, I've got my 3 points labeled there. Everything else is going to be labeling your mins and maxes and what we have. Okay, so this is odd. That means I am not going to have an absolute min or max. I'm just going to cross those off. For my relative, though, I'm going to have to click through. It will label it for you, though. If you keep it clicking, see how it says minimum? That's a relative minimum. So we want the y only. I'm going to label the full point on my graph. So I'm going to come over here. I'm going to label 1.54 comma negative 3.88. And then I'm going to make sure that I only write the y down for that minimum. So negative 3.88. I'm going to do the same thing for the max. So if I keep clicking up, relative max is going to hit, ooh, he should hit right there. Yep. So I'm going to have to label the point, negative 0.869 comma 3.06. But I only put the y number when I'm labeling it on my line, so 3.06. Now that I have everything I need, I can connect my graph. So I'm going to connect him through here, down, around, and up. Okay? All right, that is one full question. Here's how you clear it in the calculator. Hit delete, hold it down, delete everything, yes. Press tab to make a new one, and let's go on to problem 2. All right. While you copy, I'm going to go ahead and type this into my equation. All right, hopefully you have that written down. Again, all these polynomials are going to have a domain of negative infinity to positive infinity. But from here on out, now we're going to have to be really careful about our range. So when I press enter on this guy, I remind myself that it is a 4th degree and it has a negative leading coefficient, which means that it is facing upside down. My range is definitely going to go down to negative infinity, but it's not going up to positive infinity. It's going up to whatever this highest number is up here, and that's going to be based on my absolute max. So I'm going to make kind of a little connection. That range is going to go up to wherever my absolute max is, okay? And that would be included. So I'm going to square his bracket. All right, using my y-intercept, I do know that I have a y-intercept of negative 3. I can go ahead and label him on the graph. I do know that I'm going to end up with 4 possible roots, but I will not use all of them. So if you look over here on the calculator, it looks like I only cross 1 time, 2 times. So I'm going to have 2 roots. That means that 2 of them are imaginary. I don't have to know what they are. I just have to have the number of them. Okay. All right, from there, we're going to go ahead and figure out what our zeros are, what our roots are. So menu, trace, graph trace. And I'm going to write down kind of as we go. Let's just start on the left and write down everything we need, okay? All right, starting on the left. That little bump right there, it says maximum, but he is only the relative maximum. Okay, so I'm going to go ahead and label him on my graph. He's kind of right in here. He is going to be the point negative 1.61, negative 1.62. And I'm going to label him on my line as a relative max, negative 1.62. Okay, let's keep clicking. Click, click, click. I'm going to get down to this minimum. I'm going to label him as well. So he's before the x-axis. He's kind of down in this zone. Let's label him negative 0.469, comma negative 3.94. He is the relative minimum because there is no minimum, right? It's going absolutely down forever. So he's only the relative minimum, negative 3.94. We know there is no absolute minimum because both of my lines or both of my arrows are facing down forever. Okay. All right, let's keep clicking. So we're moving over to the right. Next on our list is that little 0 right there. So we know that one of my roots is going to cross at this X number right here, 0.528. Label him on the graph. Let's label it here, 0.528. And then we're going to have a bump at the top. So to the right, up until it says maximum. Now this maximum is my full maximum, right? He's my absolute. He's all the way up here at the top. Let's label that point, 1.33, comma 3.91. Since he's the absolute, I do want to fill that blank in, 3.91. And then we have one more 0 to find, or one more root to find. Right here, it says 1.85. So I'm going to label him on the graph, 1.85, and then label him on my roots, 1.85. Okay. All right. From there, I have every point graphed, so we are ready to connect our dots. I'm going to go from here, up, down and around, up all the way to the top, and then all the way back down. So this is my graph. Couple things I need us to fill in. Let me remind you that since we know our absolute max, we do need to put it in up here, 3.91. We do know our end behavior, and I think I skipped that on the first one. But our end behavior, because it is an even function, whatever we put here and here need to be the same. They are both facing down, so they are both facing to a negative infinity. I'm going to have you pause the screen, copy that. Perfect. Let's fill in the ones we missed here on this one. The negative x matches with his negative y, negative infinity. When my x is going positive, he matches with the positive y. So up is going to the right, to the left is going down. Okay. All right, we have one more problem, so I'm going to move it on up. If you would, while you copy that, I'm going to clear out my calculator and get the next one typed in for us. All right, hopefully you're done copying. If not, you can always pause it. All right, this equation looks 100% crazy pants. So here's what I'm going to do real quick. I'm going to hit menu, zoom, and we're going to go zoom out at least once, maybe twice. So zoom out once. Still can't really tell. Zoom out twice. Let me hit escape and maybe pull it just a little bit. Yeah, no, this guy is really hard to do. Let's hit menu. Let's go zoom. Let's try to fit it to our screen. Ooh, I don't know that that's much better. All right, let me do undo. So control escape is an undo. Let's leave it here and we'll just have to be really, really slow and particular about clicking through and labeling everything, okay? All right, let's start on this one with the fact that it's an odd function means that my domain is negative infinity to positive infinity. The fact that it's an odd function means it's going to go up forever and down forever. So I have negative infinity to positive infinity. Filling in what I do already know, I know that my end behavior over here, it's going to be an odd function and it's going to be positive. So it means it's facing something like this. So when x is negative, my y is negative. When x is positive, my y is positive. I don't have a y-intercept value at the end, so he's going to be a 0. So I know he's going through the origin right now. I know that my total roots up here is a 5. I don't know if all of those are real or not, but if I look on my graph over here, I should be able to see how many times it crosses. So 1, 2, 3, 4, and 5. If I kind of hover on it, it lights up. So all 5 of those are going to be real roots. I am not going to have any imaginaries, okay? So as we click through that, we are going to want to make sure we list out all 5, okay? I also know that for an odd function, I do not have an absolute min or a max, which means that from here, I can pretty much do menu trace to get all the key features that I need, okay? All right, we're going to go menu, trace, graph trace, and then I'm kind of just going to maybe start on one side and go all the way across. So since we're in the positives, I'm going to start all the way to the right, okay? All right, I am up in crazy land, 3.6, So we're going to go really slow and try to make sure that we can see everything we need to. Okay, so our first 0, if I zoom up, our first 0 is on 3. I'm going to kind of go 1, 2, 3. That way I kind of know where that is. 1, 2, 3. All right, so my first one's on 3. I'm going to keep clicking to the left. So to the left, left. All right, somewhere down here is a minimum. We got to play around with it. There it is. So 2.33 and negative 81.1. I'm going to label that kind of between the 2 and the 3. So 2.33, comma, negative 81.1. We'll fill in all the blanks here in just a second, okay? All right, we got a minimum. Clicking it slow so it lands on what we need. All right, we got another 0. So we've got it on 1 right here. So I'm going to label him a 1. That gives us 3 of them so far. All right, going slow, clicking through here. All right, we got kind of a little bump going on. There's a maximum. So let's label him. He's up top. So 0.508, comma 12. All right, going slow to the left. We hit another 0. We already knew that one, right? That one's on 0, 0. Slow to the left. Going down to the bottom, we're going to find another minimum. There it is. All right, let's label him. So negative 1.7. It's going to be closer to negative 2. And it's going to be a little bit lower than the negative 81 we did before. So I'm going to go kind of down under negative 2, but farther down than we did this one. I'm going to label him negative 1.78, negative 92.9. All right, slow to the left. We know we're going to cross that x-axis again coming up right there. So I've got a hit at negative 3. Label him. We're going to go up and back down one more time. So up. See if we can find that maximum. There it is. So I'm labeling him. I'm actually going to kind of erase this color and the line so I have space to do it. We're at negative 4.26. So negative 4.26, comma 152, so really high. And then arrowing all the way to the left. Last 0 is at negative 5. All right, and then we're going down forever. So out of all of that, let's see if we can fill in what we know. Our real roots are negative 5, negative 3, 0, 1, and positive 3. Our lowest relative minimum was the negative 92.9. That's this number. Our relative maximum was this number. That was our highest y value. That wasn't the infinity. And that means all that's left to do is to try and connect this graph to make it look like it's supposed to, okay? So if I come over here, zoom to focus on him, we're going to go up, down did this guy, up, and I just kind of connect all my dots real smooth and such. And then up forever, and this one was down forever. Okay, all right, if you need to take a second, pause the screen, go ahead and copy what you see. We are at the end of the notes for 8.6.